talking about how to graph exponential functions. So the parent function of exponential functions is f of x equals e to the x, where e is Euler's number. So it's a special number like pi that's used in a lot of math problems. We're going to be using e a whole lot more in a later unit this year. But just to get you started, e is the first few digits are 2.718281828, and then it just keeps going on forever. So notice that this is the graph of f of x equals e to the x. So it is a function that's in the form y equals ab to the x. So that is why it has a horizontal asymptote here at the x-axis, which is y equals 0. And notice that the range values increase forever in the positive direction. So let's graph f of x equals e to the x, and let's determine the domain and range. So let's go to Desmos to get us to help with this problem. So we're just going to go here and we're going to enter e to the x. Okay, so you can just type in e from your keyboard, and notice it already gives you the value of e, and then use exponent and then just do x. Okay, so here's the graph of the function. So let's zoom in to get those specific values from our table. So at -2, the value of this function is going to be 0.135. And then at -1, we have the value 0.368. At 0, the value of the function is 1, right, which makes sense because it's an ab to the x function. At 1, the value of the function is 2.718. And then at 2, the value of the function is 7.389. So let's go ahead and use these values to fill in our table. So we have -2, 0.135, -1, 0.368, 0, 1, and 1, 2.718, and 2, 7.389. So now let's go ahead and graph this function. So we have 2 and then 0.135, -1 and 0.368, 0, 1, and 1, 2.718, and 2, 7.389. So let's go ahead and connect these points to graph this function. So remember, it has an asymptote at the x-axis, and then it's going to go up in the positive y direction. So it's an exponential function, so there are no restrictions on the domain. So the domain is going to be all real numbers from -infinity to +infinity. The range is going to be restricted because it has that horizontal asymptote here at y equals 0. And then since a is positive, it's going to include values above y equals 0. So it's going to go from 0 to +infinity. So remember, we can also talk about the end behavior of a function, which is what is describing the values of the function beyond what we see in the graph. So what happens to f of x as the x values approach positive and negative infinity? So remember, the asymptotes can also give us an idea of the end behavior. Remember that a function that's in ab to the x form will have an asymptote at y equals 0. So that kind of tells you the end behavior as x approaches -infinity, right? So as x approaches -infinity, this function is actually going to approach 0, right? Because it's going to get closer and closer to that horizontal asymptote. If it has an ab to the x plus k function, then the horizontal asymptote will be at y equals k, right? So that means that as x approaches -infinity, f of x is actually going to approach the value of k. So remember, the range of an exponential function is determined by the horizontal asymptote. If a is positive, the range will be all y values above the horizontal asymptote. If a is negative, then the range will be all y values below the horizontal asymptote. So let's describe the end behavior and determine the asymptote, domain, and range of the exponential function f of x equals 4 to the x minus 2. So once again, I'm going to use Desmos to help me out with this. So I'm going to go here and I'm going to type in 4 to the x and then minus 2. Okay, so here's my function. So let's get the values that we need. So at -2, if I click on here, it tells me that the function is -1.938. At -1, I have -1.75. At 0, it's -1. At 1, it is 2, okay? And then at 2, the value of the function is going to be up here. So at 2, it is 14, okay? So let's now graph the function using these values. So I have -2, -1.938, and then I have -1, -1.75, 0, -1, and then 1, 2, and 2, 14. Okay, so let's go ahead and plot these points on our grid. So we have -2, -1.938, and then we have -1, -1.75, 0, -1, 1, 2, and 2, 14 is going to be like off my grid, so it's going to be up here somewhere. So if I connect these points, this is going to be what my graph looks like. Notice that it does have an asymptote at -2, right? So it's going to approach y equals -2, but it's not going to actually cross it. And then it's going to go up above that asymptote. Okay, so the domain, since it's an exponential function, there's no restrictions on the domain. So the domain is going to be -infinity to +infinity. The range is going to be all y values that are above that asymptote, right? That asymptote occurs at y equals -2. So the range is going to go from -2 to +infinity. So now let's describe the asymptote of the function. So you can see here, here's a screenshot of the graph, which is much better than my drawing. You can see that the asymptote is y equals -2. And now let's talk about the end behavior of the function. Okay, so what happens as x approaches +infinity? What does f of x do? And what happens as x approaches -infinity? What does f of x do? Well, notice that x approaches +infinity. Okay, so as this function goes to the right, notice that the y values are going up. So we would say that f of x approaches +infinity. Okay, when x approaches -infinity, so when x goes to the left, the f of x values are getting really, really close to that asymptote. So we would say that f of x approaches -2. Okay, so that's how the asymptotes can help you determine the end behavior of the function. So now you can pause the video and try describing this function on your own. So to describe this, remember you always want to go to Desmos and you want to go ahead and graph the function to give you an idea of what it looks like. So we have 2e to the x and then +1. Okay, so notice that we have an asymptote at y equals 1. And notice that the y values are actually less than that asymptote, right? So if we talk about it, so I'm going to go ahead and describe the asymptote first, which is at y equals 1. Since it's an exponential function, there's no restrictions on domain. So domain goes from -infinity to +infinity. And the range is going to be all y values that are less than 1. So we would say it goes from -infinity to 1. Remember, open parentheses at 1 because you can't include a value that's an asymptote. So the end behavior, okay, so what happens as x approaches +infinity? F of x is going to approach what? So let's look back at our graph. So notice that x goes on forever to the right, f of x is decreasing, right? So this function is actually headed towards -infinity. So we would say as x approaches +infinity, f of x is approaching -infinity, okay? And as x approaches -infinity, okay, what's happening as the function goes on forever to the left? Well, if we look at our graph, as it goes to the left, it's approaching the asymptote, right? So it's approaching 1. So we would say that f of x approaches 1 as x approaches -infinity. So remember, by looking at the equation of an exponential function, you can determine the domain, range, horizontal asymptote, and end behavior. Remember, it's also always a good idea to graph your function Desmos so that you can get a visual of what the behavior of the function looks like.